Welcome dear student, welcome to my channel Talking Physics with Teacher Sarkar. Today we shall learn about a very interesting topic. आज हम बहुत ही एक इंटरेस्टिंग टॉपिक के बारे में जानेंगे जिसका नाम है पोटेंशियल एनर्जी। तो इसके आगे आप लोग पोटेंशियल एनर्जी के बारे में भी ऑलरेडी पढ़े होंगे। तो मैं क्या नए व्हाट्स न्यू इन दिस वीडियो। सो if you do not know about the potential energy and its derivation, then this video is only for you. So बच्चों, if I ask you a question that this is a triangle and ABC are its vertex. Okay, a charge plus Q plus 2Q and minus 3Q are present at vertex ABC. Now, if we move this charge from position A to the midpoint of AB, let us say it A1, and charge BC and charge B to midpoint of BC, that is point B1, and the charge at C, that is minus 3Q, to the midpoint of CA, C1, and if we connect this, then what will be the work done, total work done in moving the charge? What will be the total work done in moving the charge? Okay, so this is the, for to these numericals, we need concept of potential energy. Okay, तो शुरू करते हैं आज का टॉपिक्स पोटेंशियल एनर्जी. You know about the potential energy. You know it already in gravitational chapter. अगर किसी फोर्स के विपरीत में किसी पार्टिकल को मूव करना पड़े, वर्क डन करना पड़े, तो वो वर्क डन ही उसके अंदर पोटेंशियल एनर्जी के रूप में स्टोर हो जाता है. Just like gravitational potential, we know that at the ground the gravitational potential U of A equal to 0. If we raise it by a distance h, if the particle mass is mg, then the force acted upon it is mg, which is vertically downwards due to its weight. Now, if we move this to a vertical height h, then work done is equal to force into displacement. Force is mg, displacement is h, mgh. We know that when a particle is raised or placed at a height h, its potential energy is mgh. Okay, so here we do work done against of gravitational force, against of gravitational force. The same happen in case of electrostatics. So, what is the potential energy in case of two charge? So, potential energy. Potential energy is the work done in moving a system of charge. System of charge means a number of charge, not a single charge. अगर more than one charge are situated at infinity, then if we bring those charge at a point inside an electric field, then the net work done is stored as the potential energy of a system. Potential energy in generally किसी सिंगल चार्ज का नहीं कंसिडर करते हैं. ओके, सिंगल चार्ज, इट इज नॉट कंसिडर्ड एज सिंगल चार्ज. इट इज फॉर ए सिस्टम ऑफ चार्ज. व्हाट इज सिस्टम ऑफ चार्ज? मोर देन वन चार्ज. सपोज a charge Q1 is placed at point A. When Q1 is placed, there is no any external electric field. So, the work done for bringing the charge Q1 the work done is W1 equal to 0. We consider the work done is W1 because there is no electrostatic force at the earlier. Okay. Now, if we consider a point P at a distance R from Q1, then due to this charge, the potential will be at P will be, we know, 4 pi epsilon naught Q1 divided by R. This is the potential. Now, if we take another charge Q2, which is already situated in infinite distance, infinity, and if we move this charge from infinity to this point P, Q2 charge को infinity से P point में लाना है. So what is the work done for this? If we consider it W2, that is the force, the work done by the electrostatic force on Q2. ये force कौन कर रहा है ना? Electrostatic force. So here we know that work done is given by the charge and the potential V1. Q2 into V1. If we multiply this by Q2, we can get the work done is 1 upon 4 pi epsilon naught Q1 Q2 by R. So, therefore, total work done कितना हुआ? W1 plus W2. This is stored as potential energy in this system. That is, if we consider the whole system in which Q1 and Q2 are situated, then the total work done is equal to, is stored as potential energy U, which is given by nothing but 4 pi epsilon naught Q1 Q2 by R. Okay. So, for two charge situated at a distance R, the potential energy is 1 by 4 pi epsilon naught Q1 Q2 by R. If we take three charges, then what will occur? For three charge case, the scenario is different. Suppose we draw the picture again. Suppose this is Q1, this is Q2, and again a point Q3. Okay. So, if this distance is R12, this is R13, and this distance is R23. Okay. So, again, we can say that W1 equal to 0. For charge Q2, the work done is W2, that is Q2 into V1. We get the value 1 by 4 pi epsilon naught Q1 Q2 by R12, and W3, that is taking a or bringing a charge Q3 from infinity to this point. So, W3 must be equal to 1 by 4 pi epsilon naught Q3 into W2. Q3 into W2. Q3 into V2. V2 is the potential. V2 is the potential of Q3. Potential at Q3 due to charge Q1 and Q2. So, what is the potential at Q3 due to Q1 and Q2? Now, potential for charge Q1, potential at Q3 is 4 pi epsilon naught Q1 Q3 by R13, and V2 equal to 1 by 4 pi epsilon naught Q2 Q3 by R23. Then if we add this, we can get total work done W equal to W1 plus W2 plus W3. We can write it as final result that 1 by 4 pi epsilon naught Q1 Q2 by R12 plus Q1 Q3 by R13 plus Q2 Q3 by R23. This is the total work done for the system of charge, three system of charge Q1, Q2, Q3, and this is the also internal energy U say. So for 2 charge Q1, Q2 by R, for 3 charge the mutual multiplication of the charge of mutual multiplication, okay, Q1, Q2 by R1, Q1, Q3 by R13 and so on. So this is the concept of potential energy. Okay, now we go for a problem. Suppose there are three charges. There are 3 charges, minus Q, plus Q and minus Q are situated at equal distance, say it R. Find the ratio of capital Q by small q for total potential energy, that is total potential energy if you say U equal to 0. What is the ratio of capital to small? Okay, 3 charges are situated, minus Q, plus Q and minus Q. The distance between the 3 charges are equal, that is R, and plus Q minus Q is also R. If the total potential energy of the system is 0, then find the ratio of capital Q to small q. Okay. So for this, we have to find out the total potential energy of the system. हमको इस सिस्टम का total potential energy निकालना होगा. So total potential energy is 1 by 4 pi epsilon naught into minus Q plus Q by R plus Q minus Q by R plus minus Q by 2R. The distance between 2 minus Q is 2R. Potential is a scalar quantity. So in calculation potential, we have to put the value of charges with their proper signs. In calculation of electric field, we only put the magnitudes because electric field is vector quantity and we have to find out their direction separately. But in case of potential, we have to put the sign of the charges. So this must be equal to 0. I hope you understand. So this term is 0 and Q by R is common to every term. So if with common Q by R, then capital Q minus Q into small q plus 2 small q by 2 equal to 0, or Q into minus Q minus Q minus Q, that is plus 2 into Q equal to 0. So you can get Q by R, oh sorry, here is only Q is, yeah, Q by, oh here is Q by R is common, so here plus Q by R, so plus Q by 2, plus Q by 2, Q by R is common, so minus Q and Q by R is common, so minus plus Q by 2, okay. So from here we can get that Q by 2 equal to 2Q, or Q by small q equal to 1 by 4, 1 is to. So this is the process of finding the electrostatic potential energy. Now we can do it for triangle, a problem using triangle. So a problem using triangle. sorry, this will be black. Okay, let us take another example. Let us consider three charges at the vertex of a triangle, plus q, a, b, c, minus 3q and minus q. If we take shift this charge at A1 position, A1 is the midpoint of AB. This charge minus q, sorry, plus 2q minus 2q, the mathematics. Plus 2q let us do numerical number 2. Three charges A, B, C at point ABC is plus q, plus 2q and minus 3q charges are situated at ABC. If we moved the charge plus q at the midpoint of AB, that is point A1, and plus 2q at midpoint of BC, that is point B1, and charge minus 3q at the midpoint of AC, that is C1, then what will be the neat work done? I will ask you this question in the beginning of the video. So for this, we have to consider work done equal to change in potential energy, change in P, that is potential energy, which is UF minus UY. Final potential energy minus initial potential energy. So UF is 1 by 4 pi epsilon naught, and also the side of L, side of the triangle is considered as small l. So this distance is L by 2. So 1 by 4 pi epsilon 0, what is potential energy? Q into 2q, Q into 2q by L plus 2q into minus 3q by L, sorry, this is initial, plus minus 3q into plus q by L. Okay, this is initial potential energy, and final potential energy is same 1 by 4 pi epsilon naught. Again, at this point the distance is L by 2, so the potential energy is twice than Uy. Okay, so we can again write Q into 2q divided by L by 2 plus minus 6q square. This is 2q square, 2, if we multiply this, 2q square by L by 2, the charge is same, okay, minus 6q square by L by 2 and minus 3q square by L by 2. So if we find this value, so we can find out this value as 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught. Okay, so Uy we can get 1 by 4 pi epsilon naught into 2q square by L, 2q square by L minus 6q square by L minus 3q square by L. Okay, so we can get 1 by 4 pi epsilon naught, 2q square minus 6 minus 3 minus 9, that is minus 1 by 4 pi epsilon 0, 7q square by L. This is minus 1 by 4 pi epsilon 0, 7q square by L. And what is UF? UF is just twice because of the factor L by 2, that is minus 1 by 4 pi epsilon naught 14 q square by L. Okay. Now we find the difference between these two terms. So total work done W equal to UF minus UY. So UF is, what is UF? Minus 1 by 4 pi epsilon naught 14 q square by L, and minus of minus 1 by 4 pi epsilon naught 7 q square by L. Okay. So minus 1 by 4 pi epsilon naught 14 q square by L, and plus, this term is minus plus 1 by 4 pi epsilon naught is common. So minus 14 q square by L plus 7 q square by L. So minus 1 by 4 pi epsilon naught 7 q square by L. So this is the total internal energy, total work done required for moving the charge from the vertex to the midpoint. So work done is change in internal energy. So I hope आज का लेक्चर आपको अच्छा लगा हुआ. Next day we will do with more numericals or the capacitance, capacitor problem. Okay. So if we summary the total chapter, we can find out that the electric potential energy is nothing but assembling a system of charge at a point from infinity. If the charge is like, then the work done is positive. If the charge is unlike, then the work done is negative. And obviously potential energy is work done, so its unit is joule and it is a scalar quantity. So guys, for today we know the potential energy, and if you like my video, subscribe. That is your wish, okay? But keep watching to acquire more and more knowledge. Thank you.